Hi everyone, this lesson is for Algebra 2 honor students, lesson 4.4 for f of x, terminology and systems as models. So let's get started. This is just little fun facts. So big fan of the Jetsons, and these are just some really cool inventions that the Jetsons used on TV and actually came true. So kudos to those writers who had that initiative. Learning targets. Today is going to be some programming, f of x terminology, composite functions, and using functions as linear math models. So starting off with composite functions, and the domain and range is one of the things we're going to look for. Using addition and subtraction, multiplication, and division to combine functions and obtain new functions are called composite functions. So it's like you put something in, like an f of x, and then you put another value into that f of x, something else comes out. And sometimes you can put a g of x into that f of x, or you could put an f of x into the g of x. Anyway, what comes out is, let's say, this terminology right here, which looks like this, g circle f, and that's actually g of f, which translates to g of f of x. And this right here is asking you to plug f of x into the g of x equation. Now, if I flip-flop that and I said f of g, what that's saying is this is what it's saying, f of g of x, which is saying take the g of x equation and plug it into f. So we're going to do that. We're going to talk about f of x terminology, not the band f of x, but basically we're saying what value can be substituted for x. So for example, if I said f of 4, that would mean take 4 and substitute that into the value of x. If I said, though, f of x equals 4, that's a different thing. That's just saying f of x, which we normally decipher that as a function, and this is saying that y is equal to 4. Anyway, when you say this terminology, what you're really saying is f of x. And that basically means the value of the dependent variable in a function if the independent variable is x. So let me show you some examples of that. So for example, we have an equation that says f of x is equal to 3x squared right here. There's our f of x. And then also we have g of x, different equation. Both of these are functions. One's a parabola, one's a line. Your job is to find f of 5, g of 5, and then these two values. So let's try that. So we got, this is saying f of 5 is saying plug 5 into the f equation for x. So if f of x equals 3x squared, then f of 5 is going to equal 3 times 5 squared. 5 squared being 25, 25 times 3 is 75. So f of 5 is equal to 75. Okay? And g of 5 is saying take 5 and plug it into the g equation for x. So we have 4 times 5 plus 1, and so that would be 20 plus 1. So g of 5 is equal to 21. And then f of 2 divided by g of 2 is saying take 2, plug it into the x for f of x equation, take 2, plug it into the x for the g of x equation, and then divide those two values. So in doing that, f of 2 is going to equal 3 times 2 quantity squared over g of 2, which is 4 times 2 add 1. So we have 4 times 3, which is 12. We have 8 plus 1, which is 9. 12 over 9, I'm going to reduce. So we have f of 2 over g of 2 is equal to, I'm going to divide by 3, so I get 4/3. And that's the equation, or that's my solution to that expression. F of g of x, or f of g of 6, what this is saying is like the previous slide. And you always do the inside and then out. You do the inside value first, and then you do the outside. So we have to do g of 6 first. So let's do that. So g of 6 is equal to 4 times 6, add 1. So we have 24 plus 1, which is 25. So now what this is saying, f of g of 6 is take this 25, which this equals, and now plug that in. So we've got f of 25. So second part, let me fix that. So the second part, so we have f of 25 is equal to, and then you're going to plug it into the x, or the f of x equation for x, which is going to equal to 3 times 25 quantity squared, right? So if you've got 3 times 25 squared, so you know 25 times 25 is 625. And then you're going to take that 625 and you're going to multiply that by 3. And that means that f of 25 is equal to 3 times 625, which is 1875. Let's see. Let's fix that. All right. Right on. Okay, next question. So we're going to talk about composites and then their domains and ranges. So we're going to move on from here. This is saying, suppose that f of x is equal to 2x squared minus 3, and g of x is equal to 4x. So find these values. So f of g of x is actually saying this. So you have f of g of 1. That's what that's saying, okay? So which means that I've got to take 1, plug it into my g of x equations. By the way, I have new equations. And then get that answer and plug it into the f. So f of g of 1. So if g of 1, so we're going to do that first. So this is my g equation, g of x, and this is my f of x equation, right? So g of 1, do the inside first. So that we're going to go g of 1 is equal to 4 times 1. So g of 1 is equal to 4. So we're going to take that value because we just found out that g of 1 is 4. So now we plug this value inside here. So it's going to be f of 4. So now I take this equation right here and plug that in. So I've got 2 times 4 squared, subtract 3. So 16 times 2 is 32, minus 3 is 29. So that means that altogether now, f of g of 1 is equal to 29. Okay? This equation here is now saying this, g of f of 1. And what that is saying is take the 1 and plug it in the f of x equation. And so do that first, inside out. So f of 1, we're going to do that first. So we're going to get f of 1 is equal to 2 times 1 squared and then minus 3. So f of 1 is equal to what? 2 minus 3, which is negative 1. So now this value in here is negative 1. And then I plug it into the g of x equation for x. So I've got g of negative 1 is equal to 4 times negative 1. So g of negative 1 equals negative 4. And that's my answer. And then this one is saying plug in, so f of negative 2 is saying take negative 2, plug it into the f equation, get an answer, and then plug that answer back into the f equation. Okay, so we're going to do that. So let's see. Negative 2 first, inside out. So at negative 2, so I'm plugging it in here. F of negative 2 is equal to 2 times negative 2 squared, and then subtract 3. So 4 times 2 is 8. 8 minus 3 equals 5. So this value inside here is 5. So now they want me to look up f of 5. And so now when I do that, f of 5, plug it back in. I get 2 times 5 squared, subtract 3. And that's going to be 25 times 2, which is 50 minus 3. So that means that f of negative 2 is equal to 47. Okay? The next question, and these are the answers. So you can go through these and you can look at them at your leisure. I think I have 2 pages. Yeah, all 4 of the problems are there. So the next question, this is right here is just a synopsis of what the composition of functions are and all the different ways that you can write them. So for example, f plus g of x can be split up as to f of x plus g of x, okay? F minus g of x is f of x minus g of x. And I can multiply here, and that's just multiplying the two equations together. Like if I had, for example, if I said that f of x is 2x and g of x is equal to 3x plus 1, then f plus g of x is f of x plus g of x. I would just take those two equations and add them, right? 2x plus 3x plus 1, which is going to be 5x, add 1. And then likewise subtract, I would go 2x, subtract, and make sure there's a quantity there, 3x plus 1. So that would be 2x minus 3x minus 1, which would be negative x minus 1. And then again, multiplying, I'd get 2x times 3x plus 1, right? And that would be what? 6x squared plus 2x. So what they're saying, at least on these ones right here, are very straightforward, okay? However, dropping down a little bit trickier for this one right here. That's our f of g of x, which is saying f of g of x. Take g of x, plug it into the x for f. So what I just said, so like let's say this is g of x right here. That goes into the x for the f of x equation. So you would say this one would be 2 times the x, which is 3x plus 1. And that would be 6x plus 2. Whereas if you were to multiply them up top, you lost the x. So that'd be 6x squared plus 2x. Very different, okay? And lastly, division, f divided by g of x is f of x divided by g of x. So I believe on the next slide here, what we're doing is we're going to practice what we just talked about. So at this point, I would ask you to pause the slide so that you can work these out and then check your answers once you're done. So pause, and then we'll assume you're back. Okay, so f plus g of x is, again, the same thing as saying f of x plus g of x. And so, so that's going to be adding the 2. So that's going to be 2x minus 1 plus negative 2x squared. And there's not anything I can combine because you've got a squared term, a linear term, and a constant. They're all different. This would be my answer. The only thing I would suggest is to put that in a better order, the 2x squared first, negative. F of x minus g of x, so same kind of thing. I'm going to get stuck here. So this is going to be f of x minus g of x. So that's going to say 2x minus 1 subtract negative 2x squared, like that. And then you would just simplify this one, just that very one little tiny part, and you'd say 2x minus 1 plus 2x squared. And again, the only thing I would suggest is to put this in correct standard form, which is just x squared, then x to the 0. F of g of x, that's just saying multiply the two together. So that's saying take 2x minus 1 and then multiply that by negative 2x squared. So then I'm going to distribute, right? And so that's going to equal negative 4x cubed, and then 2x times that, what is that? 2x squared. So plus 2x squared. And so that would be my answer for multiplying them together. Now, this one here is not asking me to add or subtract or multiply. This one right here is actually saying f of g of x. And that's saying, ideally, take g of x and plug it back into f of x for the x value. So we're going to take the g of x equation, that right there, and we're plugging it into the x of that equation. So that's going to be 2 times negative 2x squared, and then subtract 1. Yeah. And so that's going to give us, negative 4x squared, and then minus 1. And so that, it's kind of cool. These are pretty fun. F times f of x is saying multiply them just like this. These are both the same. So that's saying multiply f of x times f of x. So in doing that, I'm going to go, 2x minus 1 quantity squared. or 4x squared minus 2 is minus 4x, and then add 1. And then lastly, we have f of g of x, which is saying take f of x and divide that by g of x if you can, right? And so f of x on top is going to, in the numerator, is going to be 2x minus 1. On the denominator is negative 2x squared. And, you know, there's not really any, I mean, you can reduce this slightly, but you're going to end up with a fraction anyways. I mean, this isn't any better than saying 2x over negative 2x squared minus 1 over negative 2x squared. And so, I mean, like, all you would do is the 2's would cancel. You still get a negative. One of the x's would cancel. And then what I have, negative 1 over 2's canceled x. And then plus this value here, 1 over 2x squared. So, you know, that's where I'm at. And keep in mind that if you say, oh, I'm going to combine these because look, I just have to multiply by, you know, 2x over 2x, right? Well, you guys, that's where I'm going to end up back in this spot here. So be careful of that. So just again, composition of functions, f of g of x equals f of g of x. Now, the main key to this is this. X is in the domain of g, so g of x must be in the domain of f of x. So basically, the range of the g of x is the domain for the f of x. So for example, if I said that, here's my equation for f of x, right? And I'm going to give you my domain, and here's my range. Well, for g of x, okay, my domain is the same thing as my range. And my range for f of x is going to be the same thing as my domain for my g of x, okay? So finding the domain of a composition of function, it has 2 steps. The first step, you find the domain of the inside value. So if I'm saying f of g of x, the first thing you do is that g of x, which is inside, you find that domain, all right? And then if there's any other restrictions, you have to keep them. And when I'm saying restrictions, the kind of restrictions I'm talking about is when you have like that, like a denominator, you know, with these are the asymptote problems. With the parent graph, you know, 1 over x. So if this is the case where you've got a restriction, meaning you have a value on your denominator because it cannot equal 0. So we know that x minus 2 cannot equal 0. So x cannot equal 2. That's a restriction. So you know, constraints, restrictions, call them what you want, but that's what that is. So you have certain restrictions that it can or cannot be. So you have to be careful with that. Okay, so we're going to do this, and then we're going to find the domain. So first of all, we have our f of x, and this is a little bit, definitely a little bit trickier. And, you know, we did do complex fractions last chapter, so this is right up your alley. And we've got g of x being this value. We want to find f of g of x, which translates, these are the same thing, f of g of x. Take g of x, plug it into the x of the f of x equation. So let's do that, all right? So take g of x, this is g of x, plug it in to the x. So we've got 1 over, now this is my x value, x plus 2, right? X plus 2 is my f of x equation. Well, right here, that x is going to be my g of x, okay? So that's going to be 4 over x minus 1, okay? And so also, to keep in mind, remember what we just talked about on the last slide, the inside value, g of x, that inside value, what are my restrictions? Do I have any restrictions, constraints for g of x? And I do, right? You should look at the denominator and say, oh yeah, that can't be 1. X cannot, well, we know x cannot be 0, right? So I'd go x minus 1 cannot be 0, so that means x cannot be 1. So there is a constraint right there, all right? Okay, so now we're going to do the math for this problem. Now, remember, to divide, you need one term divided by one term. So this is 2 terms, right, on the bottom. So we're going to combine those together. Let me give myself a little bit of space here. So in doing that, my common denominator is x minus 1 over x minus 1. Okay, so what that then is going to give me is 1 divided by 4 plus, I'm going to distribute 4 plus 2x minus 2. So 2x minus 2 all over x minus 1. And so that is then going to translate to 1 over this, 1 divided by that. So we've got 1 over this. And so let's see, 1 divided by, so that's going to be times x minus 1 on top, and on the bottom, I get this, right? Because let me make a dividing sign a little better. This is my 1 divided by this equation here, which was this down here. So when I flip it, I'm going to get 4 minus 2 is 2, so 2x minus 2. And 1 times that value is that value, right? So you have x minus 1 divided by 2x minus 2. And yes, I know I can factor out a 2, but I'm going to just leave that there. And that is f of g of x. Now, one last thing, right? And you need to think about what values on my denominator, right, can x not equal? Because that's another restriction. So we know this can't equal 0. So that means that 2x minus 2 cannot equal 0. So 2x cannot equal 2, which means x cannot equal 1. So we already had that check right there, okay? Also, keep in mind that you've got another option here, is that when you have, let's see, 1 and negative 1, we factored out, oh, hold on, let me go back real quick to that last slide. Oops, oh, let's go back to this last slide. And that's 2x and then minus 2. Yeah, that's right. Okay. All right. So check your work, check your answers, and you're good. For this problem here, we are saying, remember solving linear systems. When we had 2 linear systems, we have an intersection point, right? Then we had like, oh, is it consistent or is it inconsistent? Well, this is consistent. Is it dependent or is it independent? Well, this is independent, because dependent would be the same line, right? So this is consistent and independent. But what that really means is that you've got an f of x equation and you've got a g of x equation, and we want to know where that intersection point is. And another name for that intersection point is what we call the break-even point. It's when, let's say, your losses become now your profits. It's like when everything starts to change in the better direction, right? Okay, so we're going to start off with a pedal boat problem. And so this is a pedal boat, in case you don't know. And of course, this book is awesome with great names like Ebb and Flow for the pedal boat problem. Anyway, they're pedal boating on the San Antonio River. They check out a boat, head out along the river for a while, and then turn around and come back to the boat dock. Yeah, we'll fix that. So to the boat dock. So we're going to say let t is equal to the number of minutes that have elapsed since they left the boat dock. You've got f of t being the number of meters that they are on the way out, and then g of t is your equation on the way back in. And so right now, they gave you the equation. So they're saying, hey, f of x is this value right here, okay? So f of t, so t meaning time, x, okay. So what you do is you're saying, well, f of t is 32t. So I want you to find these values. And these are all your, find your f of x. This is your terminology, composite functions here. So we've got f, and this is how you would write it, f of 3, and then you would say equals, and then show your work, right? F of 3 is equal to 32 times 3. And you've got f of 7 is 32 times 7. And then you've got f of 10, which is 32 times 10, right? And that's easy. That's just 320. And so for these other problems here, you've got 32 times 3. What is that? 96. You've got 32 times 7, and that's what, 224? Okay, and what you're thinking here, I hope, is that you're thinking that these are actually points, meaning 3, 96, or 7, 224. or 10, comma 320. So those are actually points that I'm plugging in. I mean, these are values that are going to be on my graph. Thinking that, I mean, if you were to graph this, right, you'd go over 3 up 96, over 7 up 224, over 10 up 320. So already I know this graph. And actually remember something too, is there's no value here. 32, right? 32t plus no value, which basically means that I'm starting at 0, 0, right? And so my graph is going up like that. So now that's my f of x, right? And I know that I could keep continuing this like that, but without the g of x equation, what's the point? So now let's find the g of x equation or g of t equation, and then they gave that to me, which is here. So now I need to plug these values in. So I'm going to find g of 18. So I would go, well, that's negative 17 times 18, add 510. And then g of 23 is going to be negative 17 times 23, add 510. And let's see what those equal. You guys can figure those out as I'm doing that. So we've got 17 times 18, negative 306, add 510, and I get 204. And then plugging in 23, I go 17 times 23, and I get that value, which is negative 391, and I add 510, and now I have 119. And so what that's telling me for this equation is that if I go over, okay, first of all, this right here is my y-intercept, right? Way the heck up here is 510, right? Whereas my other graph, if you remember, started at 0, 0, right? And I'm just going to kind of make this sort of graph that looks like this, right? Not super accurate. I know you guys can make that more accurate. But now I've got some points here besides the 510. I've got 18, right? And then I got 204. And then I've got 119, 23, and then 119. So at some point, and I know this is a negative slope, so this is going down like that, right? So at some point right here, if this is my f of x equation, and this is my g of x equation, at some point, right, it's a break-even point. Like the time is the same, right? And so your job is to graph these two on the same axis and calculate the points where they intersect. So mathematically, right, the way you would do that, let me give myself some room here. Mathematically, you would, in order to find out where they would intersect, it would be where the f of x equation and the g of x equation are equal. And so thinking about that, you can say, well, it's where f of x is equal to g of x. That's where my intersection point is, right? And so I'm going to say, well, my f of x equation, what was my f of x equation? That was, oops, wrong problem. Sorry about that. Go backwards, 32t. So we're going to say, well, this one is 32t, and g of x is negative 17t, add 510. So I'm going to take 32, and I'm going to add 17, right? So add 17, and I get what, 49t, and that equals 510. Divide 510 divided by 49, and I get about 10.4. So t equals 10.4. And so basically what that's saying is after 10.4, are we in minutes or what are we in? Are we in number of minutes? Yeah. So after 10.4 minutes, right, that's when we're going to be intersecting. Now, I would then take that value, right, and plug it into each of the equations, right? And so meaning if I want to know exactly that time, right, I've got t, I can plug that value here in here, right? And that's going to be my f of x. And for g, I would plug it in right here for that t. Anyway, I have this for you here. You can look back through it. It's the same thing that I just did, which was f of, set them equal to each other, right? And then you get 10.4, which is 10 and 20 over 49, right? And then what I just said also was to take that 10.4 and plug it back into the equations, because what that's going to do is that's going to give me my intersection point, right? And so you're going to get 10.4, which t, that's your x value, right? That's your time. And then you're going to get 33.1. And so that value right here, okay, would be time. And so it would be 10.4 comma, plug it into the other equation, and what do we get? 333.1 or 0.06. We're going to go with 0.1. So that's my intersection point, meaning that's when both the points are going to meet. And I think that I actually hid something under here. I did. Okay, so let me show you what I did here. I did put the graph down here so you can kind of see a little bit better, so it's more accurate. Okay, let me get this out of the way. Get rid of that. Okay, so what you're seeing here is this little graph here, and it's like a little bit more accurate than mine was, of course. But that's what you did. You find f of x, you find g of x, you plot them, you put them in. And at some point, I would ask you, this is a great question for, I don't know, a test. When did they arrive back at the boat dock? Okay, so you know that when the distance, right, when the distance is 0, that's when they arrive back at the boat dock. So you'd say when g of t is equal to 0. So all you're doing is you're taking your g equation, which is up here, right, and you're just setting that equal to 0. 0 equals negative 17t plus 510. Move this over to the other side. 17t equals 510. And let's see, 17 goes into 51 3 times, so that's 30. So t equals 30. So that means that after 30 minutes, after they started, they got back. Okay, so that's kind of cool. All right, so again, same thing, but in the last problem, I gave you the equations. But in this problem, I didn't give you the equations. So this is a different problem. Suppose that your family is going to buy a new air conditioning unit. If you don't know what that is, it's one of those things that like go into the wall, makes you nice and cool. One brand of air conditioning units costs $1,800. But then you have to pay $60 a month. That's like the operating fee. And then a more expensive brand costs $2,500, but is slightly more efficient and does only cost $50 a month. So what I want you to do is I want you to take a minute, pause the video, and I want you to try to write 2 equations, one for f of x, one for g of x, based on the question that I just gave you, the information that I just gave you in the question. Okay? You're back. Assuming that you're back, you have to understand that $60 a month is going to change, right? So that's my varying value. So when you're thinking of what my equation is going to be, you need to think about as far as, well, what is that? How is that going to work? I've got my f of x equation, and you just pick one, to be f of x. Here's my f of x, and then this will be my g of x equation, right? We've got the f of x, we're going to say if I buy the cheaper unit, and then the g of x is the more expensive unit. That's the 2600. Oh, I think I wrote this wrong. It's 2600. Sorry about that. I'll fix that for the class. 2600, and then $50 a month to buy it. And so this is how you would show it, right? F of x is $60 a month plus a base fee. This is my base fee right here, right? And then the $60 that's per month, and that's going to be changing. That's my variable, okay? And then likewise, I've got the $2,600 that I have to spend, and then the variable, which is the $50 a month. So as you can probably guess, I'm going to ask you, what's the break even? I mean, like, how long do I have to have my air conditioning before it makes sense to buy the more expensive brand that costs less every month? So I want that break-even point. Tell me when that's going to be. So again, you should know that if you're trying to find that break-even point, then you're looking for where the graphs are set equal to each other, right? So let's get to that. So, and I didn't ask you that here. This is something else. This is saying if I plugged in f of 100 and g of 100. So let's see, what were my two equations? So the first one was f of x, I'm going to spend $60 a month, and then, but only $1,800. And then the other one is saying g of x, and they're saying, I think it's $50 a month, and I initially have to pay $2,600. So what they're asking you here is, what do these numbers tell you about the relative costs after 100 months? How much is that? What is that? 100 divided by 12. That's 8 years, a little more than 8 years, right? Okay, so let's go through this. So after, if I had that air, yeah, and a lot of people are like, what, 8 years? Most people have like air conditioning units for like 18 to 20 years, okay? If it's a really good one, all right? Okay, so we're gonna plug in these values. So plugging in f of 100 and g of 100, what is that gonna be? So we go 60 times 100, add 1,800. You guys try to figure that out. And then you've got 50 times 100, and then plus 2,600. Okay, so let's do that. So we got, I know you just add zeros. So 60 times 100, add what, 1,800? Let's see, 7,800. Yeah, that makes sense. Okay, and then the other one, so that's how much I've spent. That's a lot. Yeah, like to save that much money. Okay, so then we've got 50, 5,000 plus 2,600 is 7,600. Ooh, hold on, 7,600. So somewhere less than 8 years, right? I've already started saving money. All right, so basically, when did I start saving money? This is just right here. This is just saying, hey, here's some information. So it costs less money to own the expensive or efficient unit if you keep it as long as 100 months, which is 8.3 years. The next question is saying plot the graphs. So on the same set of axes, again, what are our equations? So we have f of x equals 60x plus 1,800, and then we have our g of x, which is our 50x plus 2,600. So, and then just graph these. You know, you've got 2,600, we'll say, is right there. So there's 2,600 bucks. That's right out the door. And then you're going to go up 50 over 1. So that's, you know, that's quite high. And then you've got the 1,800, right, which we'll say is about here. That's your 1,800. And the rise over run is actually a little bit steeper. So this one, because it's up 60, right? So this one is not quite as steep, right? That's like that. Whereas this one is going up higher because it's, you know, slightly higher. And so what you're trying to do is, you know, you're just trying to set the axis here. And in doing that, let me open this up. It just says, well, you know, what you've got here is your 1,800 and your 2,600. Those are your y-intercepts. I want to know where, you know, this break-even point is. And so that's like the big question. That's what the whole point of this is. So like, where is this value? And so, you know, again, yes, I know you can see this very clearly on this graph. However, to solve this, you would actually set the two equations equal to each other. 60x plus 1,800 equals 50x plus 2,600. So in doing that, let's see, I'm going to subtract 50x. I get 10x. And I'm going to subtract and then divide. I'm going to say 2,600 subtract 1,800 and divide that 800 by, let's see, I think this is 800. Yeah. And then divide that by 10, and then we get 80. And that value for x, which is 80, right? That's one coordinate of my two coordinate intersection point or break even point, okay? Where's the break even point? And so for that value, you would take 80 and plug it back into one of the equations. So like you could say 60 times 80 plus 1800. So what is that? 60 times 80 equals, and then add 1800, and I get 6600. And so that would be my y. And so meaning over 80 and up, that value a little higher than that 6,000, higher than that, that's that value right there. That's that break even point. That's where they meet. That's where the that's their intersection point. So solve the system. We just did that. Find the break even point that fits the number of months for the total cost. And so basically that's just saying, hey, when is that happening, right? And we just did that. So you can check your work. The easiest way to solve a system in this part is to realize where the graph crosses, where's the intersection point, and then you break even after 80 months, and 80 months divided by 12, right, is 6 years, it's about 6.5 years actually. So is it better to, pay more in the beginning? I guess it depends on your finances, right? Okay, so we're going to go over, that's it for the lesson, actually. But I do want to go over a couple of application problems that you probably will need for your SAT when you're going to be taking that. And so we're going to start with the most famous of all time, cow problems. Okay, so here we go. We're talking about a cattle rancher. Okay, so if you don't know what a cattle rancher is, this is somebody who has a farm maybe. They have livestock and maybe horses and cows and, all that kind of stuff. And this very, very cool farmer or cattle rancher has a house right on the river. I don't know if you can see that little blue part here. So what that means is if I'm trying to fence in my cattle, right, and I buy some fencing, I don't actually need to have a fence along the water because that's like a natural barrier. And so let's do this. So we want to build a fence with the river as a boundary, and it will have 200 yards of fencing to build this remaining boundary. So let's see, how much fence do we want? I have 200 yards of fencing to build the remaining boundaries. So if I just want, I'm going to find the area and I'm going to find the domain. So let's see here. Do I want I also have one boundary to build the remaining. So I didn't give you a lot of information, unfortunately. But what we do know is that the river goes here. And so then our fencing will look something like this. Okay. And so our job here is a couple of things. Number one, we're going to draw and label. So we don't have any values here, but this is our X value and this is our Y value here. And there's actually two of those, right? So I know that 200, which is my total, fencing that I have going around here, is equal to 2 Ys plus 1X, right? So I've got 2 Ys and 1X. Now, if I had another value here, right, I'd have another value. Now, yes, I can flip those and I could say, but just leave it like that and do your Y as your value going up like that. So we have 2Y. I'm going to solve for 2Y. So 2Y is equal to negative X plus 200, right? And then for Y, once I divide by 2, I'm going to get Y is equal to negative 1/2 X plus 100. And so this is my Y value. My Y value is, let me put it somewhere. I don't have a lot of space here. I'm going to put my Y value up here. So Y equals negative 1/2 X plus 100. Now, not only do I have this linear equation, however, what I really want to know is like how much area is this going to cover, right? And so when you're thinking about that area, right, you're thinking, well, area equals, length times width or base times height, right? So it's going to be the Y times X. So my area is actually X times Y in this case, right? So, but I also have a Y value here, right? So I can say that my area is equal to x times that value. What's my y value? My y value is this value inside. So that's going to be times negative 1/2 x plus 100. Now I'm going to distribute, and I'm going to get my area equals negative 1/2 x squared, and then plus 100x. Now, this is really important for a variety of reasons. Number one, it's a parabola because it's a quadratic, right? Number two, it's an upside down parabola, meaning I notice that I don't have a value over here, which means that my y-intercept, that value right here where it crosses the y-axis, is actually 0. If you plug in 0, you get 0. So that means that I'm going to start at 0, meaning if this had been like plus 5, I would have started up here and then gone down. But it's not starting at 5. It started at 0 because there's no value there for my y-intercept. So it's going to go up, and then it's going to come back down. That's my sketch of my graph. And so from that, now what I want to do is I want to find the area. Okay, now the area is based on this equation here, right? The area also is the same as, the maximum area is the same as the value of my maximum point. And so this value, if I can find that value right there, that's my max point, that's my maximum area. So I would actually I could use a couple of things. Like, for example, I could use Desmos, and I could graph this equation right here on Desmos. And if I did that, then I would get that value of that point. Now, a couple of other things too to think of, and I'm going to do that in a minute, is this. I would also need to know that from 0 to this value here, that value from 0 to here, where my graph crosses, that right there is my domain. And then in order to find that domain or that length, right, that's that x coordinate. Wouldn't you agree? Because that's 0. That value there of my x coordinate is my domain. It goes from 0 to that value. So you would say for a domain, okay, we're not going to use a point. We're going to say our domain is 0 to whatever this point is. And how do I find the x-intercept? So think about that while we are going to take a minute, and I want you to go to Desmos, and I want you to plug this in to your equation, I want you to plug that equation into Desmos and come right back. So what I just did was I went to Desmos and I graphed this equation right here. And in graphing that equation, I got this graph. Now, what I found was this intersection point right here of my x-axis, and that value is 200, 0. Well, based on that value, that's my domain. And so when I'm finding my domain, it's going to go from 0 here all the way to 200. So comma 200, and so that would be my domain. Now, my max area for this value here, my max area is actually that top point. And what you need to think about is this. One way is to say, well, if this is 200 down here, this must be 100 because you know that's symmetrical, right? So over 100 and then over again 100 is 200. So we went over 100 and then up. This value, I believe, is 5,000. So we went 100, 5,000. So my maximum area is 5,000 yards. A fence, that's, or yards squared, a fencing. So that's that area in this space. So all this area in here, right there, that translates to this value here. That's what that is, all that area right there. Okay, so love this question. Yes, SAT loves this question also. So much that we should do another problem. Okay, just like this. All right, so I would, again, for you, pause this video and then try to do this yourself. I did come up with I think a little bit better picture of, what a fencing looks like. And if you've never seen fencing, see how they kind of split up the cows like that? That's very much what we're doing. And so again, that's what I would do. Try to set up this equation yourself and then come back and start the video again. So pause. Okay, now you're back, right? Okay, so you're designing a fence corral for your livestock. You have 360 feet of fencing. All right, the corral is going to be rectangular again. It's divided into two sections. This corral, however, is not on the river. This is like in the middle of this pasture. And so what that means is for my rectangle, I'm going to have two sides, right? So we've got this value X and we have this value here. And we know that's Y and we know that's Y. But what you also need to know is that this corral is not just this big space in here, that they took this corral and they divided it into two sections. Okay, well, that means that's another Y, isn't it? Okay, so now we've got if the width of the corral is X feet and express that as an area. So find the maximum area. How much area do I have for if I want to put like the cows here and the horses here or whatever, you know, you want to put pigs there, I don't care. All right, so come up with an equation. So hopefully you paused the video and you did that. So think about two equations, right? Like we did in the last problem. Always the two equations because we have two unknowns. So we have to have two equations. One equation was our area, right? And we do that last. The first equation is linear. And so for this value, I'm going to say, well, I've got 1, 2, 3 Y's. So I have 3 Y's and 2 X's. And that is going to be my perimeter, which is 360 feet of fencing. So there's one equation. So I need to solve for Y. And so in doing that, I'm going to get, let's see, 3Y is equal to negative 2X, okay, hold on. 2X plus 360. And then I'm going to divide, everything gets divided by 3. And so I know there's not a lot of space. I get that. So we're going to get, I'm going to put over here. Y equals 2/3. Oh, and that's a negative because I took that 2 over to the other side, right? So don't lose that negative. So Y equals negative 2/3 X. Yeah. And then 360 divided by 3 is 120 plus 120. All right. So that's what my Y equals because in my second equation, the area, which is length times width, right? Which is X times Y, length times width. I need to take my Y value, this value right here, and plug it in right there. So that means that I've got X times negative 2/3 X plus 120. So I'm going to come down here. Okay, so my area is going to be negative 2/3 X squared plus 120X. That's my formula, okay? And again, in order to do that, I need to figure out, well, there's no value here, right? So that's going to start at 0. It's a negative quadratic, so it's going to go up and over. And I need two values. Number 1, I need to find my domain, which is this value right here. Number 2, I need to find my max point, which is that value, because that max point is going to give me my maximum area. All right, so that's my max area. So based on that, there's like a couple of different ways to do it. And we haven't actually completed the quadratics chapter yet. So during that quadratics chapter, you would learn how to find the vertex point. And some of you may already know that, that negative b over 2a, comma, and then plug that in, f of negative b over 2a, right? That you might already know that and you can use that. But for right now, I suggest either you use your graphing calculator or you use Desmos. So pause your video right now and plug that into your calculator or Desmos. Now, just a note, plugging this into your calculator, you do need something called like a friendly window, meaning, you don't want to graph, you don't want to actually have, when you plug this in, it's going to make the graph super large. So what I would suggest that you do is you, try to shorten your window down and try to figure out what those points are first, okay? So, all right, so pause the video, plug this into the equation, and then come back, all right? And I'll do that. So coming back, after you've graphed this on Desmos, you should have what's called a friendly window. So my X window going across, that's like my domain, almost, but it's the window. So like, how much do I want to graph? Do I want to graph just to the domain, which would be at 180, or would I actually want to go a little bit further so that I could see the graph better? That's up to you. But the graph, my friendly window would be, you know, I could say 0 or even maybe -10, and then go all the way to, I don't know, I could even go to 250. That's a friendly window. That's where I could see the entire x-axis of my graph. And then my friendly window for y also could be 0 or -10, and that would go up past, I think this is 5,400, so maybe to 6,000 if I want to see all of my graph. Anyway, my max area, which is at 90, it looks like over 90, which is right here, right? Over 90, up 5,400. So my max area, right, of my feet, my corral, which is this value inside here too, is going to be 5,400. What are we in? Feet squared. So we have my max area is going to be 5,400 feet squared. And then my domain goes from 0, including 0, all the way, stop at 180, and then we're done. Okay, so great questions. These are really useful. And especially if you want to be a farmer or a cattle herder or something. Okay, so I think I'm going to stop here. I do have one more problem here if you want to do another problem, and then we'll be probably doing that in class, just to go through that. And yeah, going to end here. So thanks for watching, and I will see you in class.